Hi guys, good afternoon. So in the last session, we went with the MGR. Okay. So today we'll go with the DMVPN. So let me start the lab. Now, what was the issue with the MGR? Static. Yes. So if you have large number of sites, then it's not helpful. So today we'll talk about DMVPN, which is dynamic multi-point VPN. DMVPN stands for dynamic multi-point VPN. Okay, so as the name suggests, this will be what? Dynamic. We don't have to go and manually map every single site. Okay, this will be done dynamically. So in DMVPN, we will have 3 pages. Page 1, which is for your tunnel interface communication. Page 2 will be there, which will be for, you can say, end to end connect, for which we will be using what? AHI. Okay. And from here itself, we can have loopback communication also. Okay. And page 3, we will use. Okay. So phase 3 is optional. Although in the organizations we use phase 3. So I'll explain why we use, in which case we use phase 3 and in which case we can not use it, phase 3. Okay. Then we will apply IPsec over DMVPN. Security we will apply. And then we have dual hub concept. Okay. These are all the things that we are going to see in the DMVPN. Okay. For this, I have asked you to research about NHRP as well as NHS. So what is NHRP and what is NHS? Hmm.
By spoke and send request to hub,
Hmm.
that there is a message NHRP travel,
Hmm.
please register the message, and then hub will reply to go when resolution message will be sent by hub to go.
Okay, so I'll explain it in a little bit simple term. Let me open the lab. Everything is off. Keep it. So this was our MGRE lab. We'll do what? We'll create the same lab, but in this case, the site 5, we will consider it as a hub. Okay, remaining entire topology will be as it is. Okay, so let me just close this lab and we will clone it. I'll rename it to DMVPN. Okay. So one side, this one, we will consider it as a hub. Tunnel subnet will remain as it is. And site 5, this one we will keep it as a hub. Okay. So site 5, you can consider this as your HQ this time. Okay. And these are site 1, site 2, site 3, and site 4. Okay. These are branches you can see. Okay. Now, let me start all the nodes. So here, this is our hub. This is hub. This one is spoke 1. This is spoke 2. Spoke is, you can consider client, or you can say a branch where that is going to take all the mappings from the hub. So here hub will act as a server. See, in the MGRE, what was happening? That we were mapping everything. Like with the site 1, site 2, I was mapping manually. Same way with site 1, site 3, I was mapping manually. With site 1, site 4 also I was mapping manually. With site 1, site 5 also I was mapping manually. Everywhere I was giving static or manual mappings. But this time what will happen? That your hub is going to have all the mappings. Hub will have all the mappings. Okay. And your spokes, whenever they want to communicate with another spoke, first of all, they will communicate with the hub. So from hub, they are going to download the mappings and then they are going to communicate with the spoke. So first time when you will try to ping from 192.168.1.1 to 192.168.1.2, what will happen? This communication will happen via hub. First of all, your message will come to the hub. From hub, it will go to the spoke. Okay, because from hub, it will download the mapping. Then after message will go to the spoke. And after that, one time it will happen. After that, it will get the mapping. Then there will be direct communication. Is that clear? Okay. So the three phases of DMVPN that we were talking about. Yeah. Phase one means tunnel interface communication. Phase one is tunnel interface communication. Let's say communication. Phase two. Correct. Phase two will be end-to-end communication. And here for that we will use here. Then we will go with the phase three. Phase three, then we will apply. And as I said, for dual hub, we will generate a different lab itself. These all practicals we'll do in this lab. Because right now we have only one hub. Okay. Now basic configurations will remain as it is. Okay. So let me copy those configurations. Not all the configurations I will copy, just the loopback configurations I will copy. Yeah, only public connectivity. This is DMVPN. Now let's see what is the change here. Site 1, no change. Site 2 also no change. Site 3 also no change. Host names, site only. This we will change it as HQ. Okay. So these are what, this is what our hub. Then ISP also no change. So let's take the access. Let's take HQ access first. And then site 1, site 2, site 3, site 4, and ISP. No. 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 And no. Then Copy site one configuration. Okay. This, no problem. This will be overwritten. Okay. Copy site one. Copy site two. Then we have site four. Still coming up. Let's piece up. Then we have hub. Sorry, site four. Done. Now public to public communication should be there. So let's verify. To ping 12112, 13113, 14114, 13115. This is clear. Okay. So right now I have all this configuration. Now next thing is what? We will start configuring phase one. Okay. So we will configure the tunnel interfaces. Phase one, which is for tunnel. Okay, first of all, let's configure tunnel interfaces. Okay, and let's consider this under phase one. Okay. Tunnel interface. So first of all, on the hub, you will say interface tunnel one, tunnel source G0 by 0. Destination we cannot give here. So if we cannot give destination, then what we will give? Tunnel mode GRE multiple, because this is also a route-based VPN only. This is clear. Then IP address 1.5. Done. Now, same thing for other sites. We will say site 1.1, site 2, site 3, site 4, only 4. Okay. Let's copy paste. First of all, in the hub, then site 1, site 2, site 3, and then site 4. So right now I have copied this configuration, and you can see everywhere my tunnel interfaces are up. Will I have communication? Yes or no? Hmm? There is no route. No, I'm talking about tunnel interface communication. Why? Because mapping is not there. The mapping is not there. Okay. So right now, if I try to pin from here, if I say do pin 192.168.1.2, I don't have any mapping here, right? So we will say next thing is what? DMVPN phase 1, which is for tunnel interface communication. Mhm. Okay. So now remember what will happen here, that in each and every spoke, see, earlier we were doing static mappings, right? So every single spoke will have a static mapping of the hub only. Yeah. All the spokes will have a static mapping of a hub, right? So if all spokes will have static mapping of a hub, automatically hub will get the mappings, correct? Let's see. So here, first thing, all spokes will have a static mapping of the hub. Okay, and what kind of mapping? NHRP map. Okay. Hub will not have any static mapping for the spoke. This is clear. Now let's see. So first of all, site 1. So we'll say interface channel 1 IP, NHRP. Hmm? Network ID. Anything we can give? IP, NHRP map. Then let's say you want to reach to hub only, because only spokes will have mapping for the hub. So 5, and how do you reach here? 15115. Okay. And if we talk about hub, so like I said, on the hub, I will not give any mapping. So if I talk about HQ, on the HQ, what I will have? I will have interface, tunnel 1, and IP, NHRP, network ID 10. Then after, I will not give any mapping here. Okay. So let's see. Tunnel will come up. Tunnel we already gave, right? The tunnel mode is GRE multi-point. So when we say multi-point, it's already up. You can see. Okay, but only tunnel interface communication is not there. Now we just have to tell our device that, okay, if you want to reach this tunnel IP, use this public IP. Okay. So see here, first of all, in the HQ, copy, paste, done. Then site 1, copy, paste, done. Let me test the communication. So right now, if I check here, do show IP and HRP, nothing. Okay. Check here, show IP and HRP. And then I can check here. Yeah, that's it. Show IP and HRP should be sufficient. Nothing. Now from site 1, what I'll try to do is I'll try to ping. Do ping 192.168 1.5. Okay. Let's see here. So you can see tunnel 1 is created. Okay. But right now there is no communication to show IP and HRP. And here we can see that there is a static mapping. Okay. Same way, this static mapping we will create everywhere. Okay. So see here. Site 2, same, no change. Site 3 also, no change. Site 4 also, no change. This is clear. Okay. Site 1 is already done. Let me only copy this one. Copy. Site 2, Site 3, Site 4, ISP not required. Now everybody has static mapping. We can check here. Do show IP and HR. Here also we have static mapping, and you can see static mappings will never expire. Okay. Do show IP and HRP. This is also there. Do show IP and HRP. Here also we have. Now show run interface channel 1. There will be no loop. GRE multi-point we have given. Okay. Network ID also we have given. Now what? See, whenever a site wants to communicate with another site. Okay. So first of all, what we can do is We will also tell, see, right now when site 1 wants to communicate with site 2, it will not be able to communicate. Okay. Why? Because it needs to know that if any other site is there, it will download the mapping from where? From the hub. And for that reason, what you will do? You will use one command here. That is IP, NHRP, NHS, and who is the server? Which is your hub, right? 192.168.1.5. Done. Let's paste this command. Paste, paste, paste. This and this. Show IP, MHRP. Interface tunnel 1, IP, MHRP. Connect interest map. No, here we don't need to specify, right? This is up. Wait a minute, I'll check it. This is fine. Okay, configuration wise, we don't have a problem. Here our tunnel interface communication should happen. So what we can do, sometimes this kind of problems happen. Okay, so what you'll do, just all sites interface tunnel 1 shutdown and no shutdown. Copy, paste, 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 paste. Hmm? Hub, we don't require any static mapping. Yes, in Spoke we have, right? Route we have given. If you see here, whenever we configured, we gave a default route. That route, what you're talking about, that we will need for these loopbacks. Right now, we are not communicating with the loopback. Loopback communication in the phase 2, when we will use AERP. Okay. That's very good. Show IP and yeah, see now automatically once I shut down and no shutdown, these mappings are automatically completed. Okay. And now our tunnel interface communication is there. So if I say do ping 192.168.1.5, so I have communication with my tunnel interface. Okay. Now what? If you see that do show IP NHRP. So right now I have only one static mapping, correct? I have only one static mapping, that is for my hub. Now what I'll do is I'll go and I'll say do ping 1.2. That means site 2 I will ping. And just because I want to show you that how the packets are traveling, so I'll say trace route 192.168.1.2. Now let's try it. First time it will download what? Mapping from the hub. So you will see my packet will still go to 1.5 only. See, first my packets goes to 1.5, that is my hub. Once the mapping is downloaded, now you will see it will go to site 2. Okay. And if I check do show IP NHRP, now this mapping has been downloaded for the spoke. And you can see this is a dynamic entry. And dynamic entries have a expiry time, that is by default 2 hours. And here it is static mapping, which is never going to expire. Same way, I can go and ping others also now. And you can see earlier first time when I tried to go to 1.2, first of all, I was going to 1.5, then 1.2. Now if I try again, now I should go directly. Why? Because I already have a mapping.
Okay.
Yes, see here that if you want to go to 1.2, you can directly go to this address 12.1.1. Okay. Now what? Next thing, we can go for trace route 192.168, 1.3. Now again, it will download the mapping. So first time from the hub, and then second time directly. See, first time going to the hub. And now if I try again, it will go directly to 1.3. This is clear. So here our phase 1 is done. Now second is what? End-to-end communication we need. So for end-to-end communication, what we are going to use? EIGRP we are going to use. Okay. Okay. So now let's go and configure EIGRP. So phase 1 understood. Now DMVPN phase 2. Input and communication using EIGRP. So let's configure. First of all, in the HQ, we will say router EIGRP 100. No auto summary. And then after networks 10.5.5.0 network 192.168 1.6. Copy. Site 1 1.1. Site 2 will be 2.2. Site 3 will be 3.3. Site 4 will be 4.4. Okay. Now Let's copy paste. Copy, paste in the HQ. Copy, paste here. Copy. Site 2. Copy. Site 3. Copy. Site. Okay. Now let's check. Do show IP, EIGRP, neighbors. Anything? No. If I check my tunnel communication, do ping 192.168.1.5. Communication is there. Communication is there, but I am not having what? EIGRP neighborships. I'm not having EIGRP neighborships. Now, what is the problem? All spokes and hub. And tunnel to tunnel communication is also there. Now, what is the issue?
But look at ID is not mapping.
But your neighborship will come up using tunnel interface, right? Because common subnet is tunnel interface. Then why? Think about it. As soon as you configure EIGRP on a interface, what happens? Hello message is sent on which address? What is the multicast address? 2240010. Now, if you want to reach 2240010, do you have a mapping for it? No, we don't have a map. So what we need to do here, we need to give one command. Back here, EIGRP, and you can see here, even if I will go and shut down my tunnel interface. Okay. Even if I will do that. Anything? No. Let's see something here. Do show, do debug IP packet. Let's see what is the process going on in the backend. We might see some logs. See here. What we are getting. From 192.168.1.1 to 2240010. Trying to send a multicast or broadcast. But what is the problem? That means mapping issue. That means what? Mapping issue. Okay. Now, stop the debugging. And now, I will go and give one command. Everywhere. Interface, tunnel 1. Okay. And I'll say IP, NHRP, map, multicast, and how to map? Dynamic. This is done. Now let's see the debug. What is the status here? Is there encapsulation failure now also? Still there is. Okay. Okay. Same thing. I will go and give everywhere. Interface, channel 1. IP, NHRP, map, multicast, dynamic. Okay. But Still there is a problem. Failing. Yes or no? But I won't see right now. I want to create my neighborship with whom? First of all, I want to create my neighborship with hub. So instead of saying here dynamic, okay, if I say that map multicast also with 1.5 only, now what happens? Let's see. This time, do you see something? Trying to send full packet. Okay, that is coming, but this time it is trying to send full packet also, right? Okay. Same thing I apply here also. Let's see. Interface. Okay, before that, let's go and copy. Application is still failing. Do show IP geographic neighbors. Okay. Do show IP. To show IP geographic neighbors. So I'm having one neighborship here, right? But this neighborship will keep on coming up and going down. Okay. Here I have. What about here? Here I'm not able to see right now. Okay. Okay, this will keep on flapping. Okay, see, new adjacency. So neighborship is forming and flapping. Same thing I'll do here also. Here, GRP neighborship will not come. Okay. So we will map multicast address. Okay. Or we can say we will create an NHRP mapping for the multicast. Okay. So on the HQ, what do you have done? The is channel 1, IP NHRP map, multicast time. See, right now we will face few problems. Why? Because in the real scenarios, when you will do the configuration, you will do the configuration all at once. Okay, right now I'm just doing some configuration, then stopping, then doing some configuration, then stopping. So multiple times we will have to bring down the tunnel interface, bring it up. Okay. Then on the other sides, so let's say all spokes, you will say interface, channel 1, IP NHRP map, multicast, and map it with 1.5. Okay. Copy this. site 2, site 3, and site 4. Okay. Here still we don't see, and here we can see that it's just flapping up, coming up, going down, coming up, going down, like that. Okay. Now again we need to go and shut down and no shut down the interfaces. Copy. Now you will see that all the sites, they will say new adjacency, new adjacency, new adjacency, and new adjacency. Right? Check here. Do show IP EIGRP neighbors. Here still nothing. And here it is flapping. Okay. So it will go down and come up again. It will keep on flapping. What we should see here, do show IP route. Right now, one static route I have. Wait for it to come. Do show IP EIGRP neighbor. Nothing. So IP EIGRP neighbors. Still nothing. Now here adjacencies are coming up. Here also, here also, here also. And here it's not showing anything like EIGRP neighbor. If somebody is becoming neighbor with HQ, HQ should also be a neighbor. So you can see became a neighbor here. And if I check do show IP route, the route is not there. Okay. So some more configuration we have to do here. Right now you can see that all of these, they will become the neighbor with whom? Only the hub. They will not become neighbor with each other. Spoke to spoke neighbor, they will not become neighbor. Okay. Now, then how they will become the neighbor between spoke to spoke? So what we have to do here, see your HQ down again up. Okay. See in EIGRP, we have one thing that split horizon. What is split horizon? Huh? What is split horizon? Okay, so far I believe everything is good between us. Multicast we have given everywhere. Okay. This is public IP we have to give here. Slight change. 15.1.1.5. Copy. Okay, this is very easy. But this should, yeah. This will be a public IP. Okay. So now here we can see that do show IP ARP neighbors. So hub has become neighbor with everybody, and spokes, they will become a neighbor. with the hub only right now. But between hub spoke to spoke, there is no neighborship right now. Okay. So if you want that the neighborship should come up between spoke to spoke. Right now, if I try to communicate, what will happen? Let's say, for example, if I say do ping 10.2.2.2. So let's see. Let me go with the trace route here. How this thing will happen. That do I have a communication or not? So right now it does not have a mapping, right? See, so I'll not be able to reach, right? Why? Because if I say do show IP route, do I have a route? No. Okay. And if I want to reach the HQ, I'll be able to reach the HQ. Do show IP and sorry, do ping 10.5.5.5. Hmm. Now I want that, okay, the EIGRP neighborship should be between these two, spoke to spoke. Okay. So if you want EIGRP neighborship to come up between spoke to spoke, okay, here we do not. First of all, here we will get EIGRP neighborship between hub and spokes. But there will be no neighborship between spoke to spoke. So right now, spoke to spoke, no neighborship at all. And for this, what we will have to do? We have to disable the split horizon. Okay. Or you don't know. Okay. Split horizon. It's a loop prevention mechanism in your dynamic routing. That through whatever the interface they are learning a route, they are not going to advertise it through the same interface. Okay. So for EIGRP, neighborship between spoke to spoke, disable EIGRP split horizon. Okay. So we'll go on the spoke and we'll say router EIGRP 100. No IP EIGRP. No, no EIGRP. No. We have auto summary, neighbor metric, offensively distribute timers variance. Hmm? No, not router ID. No EIGRP. Yeah, that is what I'm checking, but no, it's not showing IP command here. In this router model. There is no IP command here. Oh, right. What about here? No. Here also we don't have. Hmm. Interface Z0 by 0. No IP. Yeah, here it is. It's an interface level command. No IP, split horizon, EIGRP, and AS number we will give, which is 100. Okay, this is what we will configure on the interface. So you will say interface V0 by 0, no IP, split horizon, EIGRP 1. Copy, paste, 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 paste. Again, we have to bring it down and up. Copy, this down. We have adjacency. Do we have the routes now? Do show IP route. Only for R5 we have. Do show E route. Only for same HP only. Here also HQ. Here also HQ. And here we have all the routes. In this we have done, bringing down. We have configured this also. We are not getting the routes here. Why? Phase 3 after this we don't require. Oh, got it. It's not. Problem is not this. Tunnel interface. Problem is tunnel interface. This will be interface tunnel 0. And here we have to disable it. Copy, paste. Tunnel interface is down. Okay. Split horizon changed. graceful restart. Issue IP route. Now you can see we got the routes. Okay. Everywhere we'll get the routes. Do show IP route. Okay. So that means now I will have communication everywhere. Okay. From site 1, do ping 10.2.2.2. I have the communication. 10.3.3.3. I have the communication. 10.4.4.4. I have the communication. But the thing is, do this route 10.2.2.2. See here how the communication is happening. Because when we check the routes, right now, the routes, here it's not coming. You can see it is going where? Up. My traffic is going where? Up. Why traffic is going where up? Because see here, next stop is what? The next stop is 1.5. That means hub is, whenever hub is sending these routes to the spokes. So hub is sending them as a next stop as itself. Okay. So that is the reason that the traffic is going to the hub. Now, why this is happening? Again, EIGRP has a feature that is next stop self. That means whenever EIGRP is advertising a route, so it is considering itself as the next stop. So that feature also we have to disable here. Okay. So how do you disable? Go on the hub, because hub is advertising. Interface, tunnel 1, no IP. Okay. Next stop self. Okay. Next stop self, EIGRP 100. Now, again, everything will change. And now when these guys will get the routes, they will have the correct ones. So this thing is do show IP route. Now it is correct. And now if I say do trace route 10.2.2.2, they will go that way. So this is how end-to-end communication. Okay. So here, this thing you will do it on the hub, and here we will get spoke to spoke communication, but the traffic will pass via hub. Why? Because when the hub is advertising the routes, it is advertising itself as a next hub. To overcome this, we need to disable next hop self for EIGR. So you will say interface tunnel 1, no IP next hop self EIGRP 1. This is clear. And once you use this no next stop self, you will not need phase 3. You will not need phase 3 because phase 3 does the same thing. Phase 3 does the same thing. That here what is going to happen? your routes will be advertised with the correct next hop. This is what your phase 3 does. But over this thing, okay, we don't really use this no next of self command. Instead of this, we use phase 3 only because that provides us better optimizations. Okay. So instead of using this, so first of all, let me mention here, we do not need phase 3 now. Okay. But phase 3 provides better optimization. Okay. So instead of using no next of self, what we are doing, we use phase 3. Okay. So when you will go with the phase 3, what you will do on the hub, you will say interface tunnel 1 IP next hop self AGRP 100. First of all, you will enable the next hop self because we don't want to disable it. And once I will enable it, again, you will see my routes will come from hub only. Now see here again. My routes will be advertised via the hub only. This is correct. So here we will do one thing, that on the hub, we will give one command, that is interface channel 1, and you will say IP NHRP read. This is the command we are going to use. And on all the spokes, you will use IP NHRP shortcut. Okay. So here what you will use? You will say IP NHRP redirect on the hub, and on the spokes. Okay. On all the spokes, you will use interface tunnel 1 IP NHRP short. This is the command you are going to use. Copy this, paste it. Okay. Now, once I give this, check. Right now, like this, we need to shut down and no shutdown. So many comments are there. Hmm? Only DMVPN configurations are lengthy. After that, it's not lengthy. Still, it's not coming up. IP NHRP redirect. Yeah. That means usually we don't disable it. Okay. To show on interface channel 1. This is fine. Hub configuration. You show running interface tunnel 1. IP NHRP redirect is configured. This is also okay. Split horizon we have disabled. Next of self is enabled. That is not an issue. So it's advertising itself as a hope. Show IP NHRP. Do ping 121. Okay, let me try like this. Do it's route 10.2.2.2. I don't think we are missing now anything. Here shortcut, here redirect. This is fine. Then after IPsec on the now. See, the communication this time is happening directly. Okay. You show IP route. So the routes might be like this, but you can see my communication. Okay. If I say do trace route, so my tunnel is being negotiated directly. Okay, one time it will take a mapping from the hub, and after that my tunnel will be negotiated directly. Okay, so for going for 10.2.2.2, we are directly going to the 1.2. So my tunnel is direct, only this route is showing like this. Okay. The overall idea behind your phase 3 is what? That your spoke to spoke communication. So between two spoke, there should be a direct tunnel. Every time it should not go to the hub and then the traffic should go to the spoke 2. It should not happen. Okay. But site 1 connect to the site 2 hub. Sorry. If site 1 is connected to the site 2, what is the information they are connecting? It's more or in the site 1 communication. No. Because tunnel, tunnel will be created. One time it will take it from the hub. Once the mapping is taken, after that the communication is direct only. Now the communication is not coming to the hub. Okay, and you can verify that. Now if I try to ping from here, these are all EAGRP messages. Let me say do ping 10.2.2.2. So my ICMP will never come here to the hub. Okay, this is clear. Okay. Now this is DMVPN configuration done. Now we need to apply IPsec on. Okay, so how do we apply IPsec? Configure IPsec, and to configure IPsec, what we will say? So it's a camp policy 10. Then we'll go with hashing of application pre-share. Group is 14. Encryption is AES. Lifetime, let's leave. Crypto. Okay. Address on the hub, we can keep it 000. Okay. Or else on everyone also you can keep it, no problem. Okay. Then you will say crypto. IP set. Transform set. Set. Attachment. We can use out. Now here, if you want to change the mode to transport mode, that also you can do it. Okay. So we can simply say mode transport. Okay. Then after crypto IP set profile, let's say VPN profile set transform set so is tunnel 1 tunnel protection IP set profile and VPN profile. And this is the configuration we are going to use. Copy. The camp is on. All the neighborships and everything should be good. And here also in the capture, you should see, you can see identity protection main mode and quick modes. Okay. So now again, we can go and try to print. Do print 10.2.2.2 encrypted. And here now even your EIGRP messages will be encrypted. Okay, so you can see how many tunnels are established. So do show crypto. I select them and say these are all the tunnels. Okay. So this is how you can perform DMVPN. Okay. See here again. First of all, we have the basic configuration. So first of all, basic configuration is there. Then we configure the tunnel interface, and since it is multi-site, so we have used tunnel mode GRE multi-point. Okay, instead of destination. Then we started providing tunnel interface communication. For tunnel interface communication, what we needed? Mappings. So on the HQ, we will not give any mapping here. And on the spokes, that is all your other sites, you will give a static mapping. And for spoke to spoke communication, you will also tell that, okay, if you want to communicate with other site, then this is your next stop server, right? So which is our HQ or hub. Okay, so on all the spokes, you will give the same thing. Okay, so either here itself, you can say this is on all spokes. So this configuration will not look lengthy to you. Okay. You will do this. After that, on all the sites, what you can do? Tunnel interface, you can bring it down and up. So phase 1 will be done here. Here you will get the tunnel interface communication. Once this is done, after that, you will start phase 2. You will start using EIGRP. So we will configure EIGRP on all the sites. Okay. Once EIGRP will be configured, here we will see that EIGRP neighborships will not come up. Why? Because EIGRP sends its packets on the multicast address. And for that reason, on the HQ, what we will do? We will map the multicast dynamically. And on all the spokes, we will map it with the public IP of your hub. Once this is done, your AGRP neighborships will come up. Okay. Your AGRP neighborship from your spokes to the hub will come up. Okay. And spoke to spoke, there will be no neighborship. Okay. There will be no neighborship. And here we will not have spoke to spoke communication. Okay. This will be here. There will be no spoke to spoke communication. Okay. There will be no spoke to spoke communication. So for spoke to spoke communication, what we will do? We will disable. And why this communication will be not there? Because there will be no routes for other spokes on a spoke. Because your hub will not advertise the routes. Why? Because of the split horizon. So we will do what? We will disable the split horizon. Okay. Now, once we disable, then we will get what? Spoke to spoke communication. Okay. So we will get the spoke to spoke communication, but the traffic will start passing via the hub. So why it is happening? Because when the hub is advertising the route, it is advertising itself as the next stop. Okay. So to overcome this, you can do what? You can disable this next stop self. Is that clear? We can disable the next stop self. So once you disable the next stop self, everybody will see the correct routes. Everybody will see the correct route. Now, once this is done, you don't really need what? Phase 3. Because phase 3, overall reason behind phase 3 is what? That spoke to spoke direct communication is there. So if you already have a route with the correct next stop, then your spoke to spoke communication is there. But in real networks, we don't really go and use the no next stop cell. So what we'll do, we'll use the phase 3. In the phase 3, what you have to do? On the hub, you have to give what? IP NHRP redirect. And on all the spokes, you have to say what? IP NHRP shortcut. This is done. Then you just have to go and configure IPsec. This is your phase 1, phase 2, phase 3, DMVPN and IPsec. Now tomorrow we'll do what? Dual hub. So tomorrow in this configuration, there will not be a very huge change. Only your hub 1 and hub 2, both will have same configuration. Today, whatever we have configured on the hub 1, same thing tomorrow we'll configure on the hub 2 also. Spokes are right now having static entries only for one hub. Tomorrow they will have for both the hubs. Right now, hub is not having any static entry for anyone. Tomorrow hub will have for hub 1 will have for hub 2, hub 2 will have for hub 1. That's it. That is only the change. Okay. So if this is done, tomorrow will be very easy. Is that clear? So which one? Spoke is not advertising, right? Spoke is having one direct communication with the hub only. Spoke to spoke neighborship will not come up. So even if you use no next stop self, doesn't matter. Yeah, on spoke. Even if you configure or don't configure, doesn't matter. Only on the hub, these things have to be configured. This also and this also. Clear? So this is your DMVPN. Online people. This is one lengthy configuration. After this also, you will not have very lengthy configuration. Only DMVPN has this kind of configuration. Okay. All right, then. I'll see you guys tomorrow. Have a good day.